All right, today is Combinatorics. What a name. It's everything that we've been learning: permutation, combination, the fundamental counting principle. You're taking all of that, and we're going to use probability with what we've learned. So if you have not finished the other videos and have worked up to this, please go back and watch those and master those before trying this one, okay? All right, so remember that probability is the number of ways that something can happen out of the total number of outcomes. That's going to help us with all of our problems today. I found this free flowchart online. I thought it was very helpful. Does order matter? Are the items the same? Do you care about every value? To help us. Okay, so let's look at our example here. We have 10 math teachers in high school. The principal wants to form a committee by selecting 3 of them at random. We're just going to call them Mr. A, Miss B, and Miss C. Of the group of 10 math teachers, what is the probability that all 3 of them will be on the committee? Okay, so I kind of give you a visual there. Notice there are 10 teachers, so the circles there. So what is the probability that A, B, and C are selected? So does order matter? No. So that's a combination. We just want A, B, and C. We don't care if it's CBA, BCA, doesn't matter, just as long as it's those 3. There is only one way to get the group A, B, C. Okay, yes, I can have different orders, but again, we said order doesn't matter. We just want those 3. And so that's only one of the combinations out of all the combinations possible, right? So going back to that first slide, what probability is, we're going to do 1 because there's only one outcome that is A, B, C. Okay. Then we're going to divide that by how many different outcomes are possible. So I could have ABC, I could have ABD, I could have ABE. A lot, okay? We can't list them. So I can type that straight into Desmos as is. So the 1, remember the divide button is the question mark. So shift question mark will make that divide button. Type in NCR 10,3. It'll give me the decimal first. It always does. You hit the little fraction button that you should be a master at now. That is 1 out of 120 different ways to get ABC. So that's not very likely. It's actually 0.0083 as a decimal rounded, which is not even 1%. So 0.83%. All right. These little side note, these notes will be just a tiny bit longer, but I do think that this concept's a little harder. So if you need to take a break, press pause at any moment. All right, let's look at a different one. We got a high school that's planning a musical, and they're going to do West Side Story. The director is interested in the number of ways to choose a lead singer and a backup singer from 22 students that auditioned. What is the probability that Alicia is selected as the lead singer and Juan is selected as a backup singer? Okay. So in this example, order does matter because Alicia being the lead singer is different than Alicia being the backup singer. So we're going to be using permutation. Again, there is only one way to make Alicia the lead singer and Juan the backup singer. So this one works very much like the first example, except we're using permutation instead of combination. Remember, bigger number always goes first. So we get 1 out of 380 different ways, which is even smaller of a decimal than the last example. It is 0.26%, so not about a fourth of 1%. Very small chance that that would happen if it's all random, right? Okay. Next one, we have a math class. It's got 14 girls, 15 boys. A teacher likes to have the students come to the board to demonstrate how to solve some of the math problems. During the lesson, the teacher randomly selects 6 of the students to show their work. What is the probability that all 6 students selected are girls? Okay, so again, we're just selecting girls. Order does not matter. which one's selected first, second, third, so forth. Okay. Notice there are 29 different people in the room, right? 14 plus 15 is 29. So 14 girls, 15 boys. And we're going to be choosing 6 of them to go to the board. So the total outcome is from the 26, we're going to select 6 of them. However, if we think about just the girls, out of the 14 girls, we want to select 6. Hold on, telephone. So the number of ways would be combination again, 14 choose 6. Let's put it all together in a fraction for probability. So the number of ways it can happen is combination of the girls and then combination of everybody. Again, just type that in your calculator. Don't stress over all of the little nitpicky algebra. There we go. 11 out of 1,740. When you're putting these answers in, I do suggest putting them in as fractions. Okay, so remember this button right here, clicking that on Desmos will give you the fraction. Again, very small percentage. All right. What about golf balls? There are 9 of them. They're numbered 1 to 9 as the picture shows. 3 of the balls are randomly selected without replacement to form a 3-digit number. What is the probability that the 3-digit number formed is less than 200? This one's kind of a tricky one. So we have to think about this, that something less than 200 that is 3 digits would be something from 100, because that's your first 3-digit number, all the way to 199, right? So no matter what, you have to have 1 in that first position. As long as you have 1 in that first position, everything else works, right? So 187 works, 156 works, 165 works. So you have to have the 1 in the first position in order for it to work. So what is the probability of drawing a 1 for that spot right there? Well, there's number 1 out of 9 golf balls. So there we go, 1/9. And that's it. That's the overall probability. So that one actually didn't need a combination, permutation, whatever. Okay. What about having 11 seniors and 5 juniors who are sprinters on high school track team? The coach must select sprinters to run the 800-meter relay race. What is the probability that the 2 seniors and 2 juniors will be chosen for the relay race? All right. Again, order does not matter. I know once they are chosen, we will put them in order, but we are just saying what is the probability of 2 of them being juniors, 2 of them being seniors, okay? Not who was chosen first, who was chosen second. All right, so how can we choose 2 juniors? Well, there's I think I did these backwards, didn't I? So this is actually seniors. Cross that out if you're writing this down. So how can we choose 2 seniors? Well, there was 11 seniors, so it's going to be 11 choose 2. Okay. Again, switch it up. How can we choose 2 juniors? That's 5, because there's 5 juniors, choose 2. So I have those flip-flopped. Okay. Sorry. Typo that I'm not fixing right now. How can we choose people for a relay team? So how many are there total? There's 5 plus 11 is 16, and we're choosing 4 of them. What happened to my video down here? I don't know. You might just have to hear my voice and this really awkward pause that my video is on. Okay. We're going to keep on going with the video here. So NCR 16 choose 4. We're going to put that all together, and here's what that looks like. That's the total number of outcomes, so that's going to be our denominator. It's an and statement, so we need to multiply some probabilities. So I'm going to type all of this in my calculator. Both of the combinations that are the ands, and then our denominator, for a fraction of 55 out of 182. Okay? Which, again, is about 30%. All right. A 6-sided die is rolled 8 times. What is the probability that the die will show an even number exactly 4 times? Order does not matter. We don't care what we did first, second, third, so forth. Okay. So we want 8 times, choosing 4. So that's NCR 8, choose 4. Because we're rolling it 8 times, we want it to choose 4 times. What's the probability of an even number? Well, that's 1/2. What's the probability of an odd number? That's also 1/2. So this part is the little bit of a confusing part. So make sure to write it down, maybe pause for a second, write it all down, because I'm going to tell you what each part of this is. Okay, so we have the original combination first. Just what is the combination? Then we have the probability of an even number. And how many times do we want to select that even number? Well, we want to select it 4 times. Then we have the probability of an odd number. If we select the even number 4 times and we're doing a total of 8, that means I must have an odd number 4 times. Okay, so that's all this says. It says if we want even exactly 4 times, that means that we want odd the 8 total times minus 4. So that's also 4. And then Desmos tells us that that is 135 out of 128. That's approximately 27%. But again, when you are doing your practice target, I would recommend doing fractions. All right, and that ends 3.5, which will end the unit this year.